Alrighty, class. All people in class now, the ones staring at their phone right now. Write me out. Alright, so we're looking at these notes. Identify where a function has no derivative. So if we're looking at this, we have a couple things that I need to rewrite it, just so I can see something. If something is being raised to the 4/5 power, the top number, the 4, is my power, and the bottom number is the, very good. So it is a fifth root of x minus 2, parentheses, and all this is being raised to the 4th power. Now, order of operation on this, it's either or. You can do either first because 4/5 power is happening at the same time. The power and the root is happening at the same time. So you could do whichever is easiest or whichever comes first. I personally like getting to the root because if I take care of the root first, that means that I'm going to be dealing with smaller numbers. So I'm going to raise a smaller number to a power. But if I do the power first, I'm going to have a large number I have to take the root of. And I don't memorize all my roots. I really don't. Apologize. I suck at that. I don't know everything to the 17th power. Okay? I'm like somewhere in like the 15 range I start dropping off, and then after that. Yeah, I'm joking. I really don't know any of that. I don't. I suck at math. Anyway, all right, so we're going to show that this, if it's a fifth root, can I have negatives in a fifth root? Yes, I can. Good job. I can have negatives in a fifth root. So that means that I don't have to worry about the left side and the right side of this. I don't have to worry about this. If I have a negative, it's not going to work out. So looking at that, so if it was a square root, I would have a domain restriction. So if this 5 was a 4 or a 3, or a 2, a 4 or a 2, I would have a restriction where I cannot have negatives inside the radical, period. No matter what my power is, I could not have that. So that's what I have to go through and take a look at. So given those things, I am allowed to have it. So at 2, what's going to happen at 2? 2, I'm going to go ahead and do what? What's 2 minus 2? 0. What's the fifth root of 0? 0 to the 4th power? 0. Yeah. Okay. It's still all going to be 0. But then we're going to take a look at the graph for this one. So you guys take a look at the calculator, please. All right. Okay, here we go. So I'm going to go and graph this one and see what my graph is going to look like to see if it is going to be. So now it was open parentheses, and it was x minus 2 close raised to, right? And all I have to do for my exponential power, control divide. And so now I could actually see that there. For those people with their calculator in front of them, not staring at their phone, falling asleep looking at TikToks. Where's your calculator? Write me out. Charger right here, especially if it's dead, just go swap it out, put that on the charger, and grab one to use. Same thing? Oh, okay. And so this was 4/5, so 4 over 5. Charging. light doesn't come on. Anyway, all right, so I'm gonna go ahead and hit enter. What's wrong? Oh. All right, so let's take a look here. So x minus 2, right?
Yeah.
To the 4/5?
Yeah.
Okay, let me, that's weird. Okay, I'm gonna tab it to try and see if I could actually fix this one. So open parentheses, x minus 2, close, raised to 4/5. Still same thing, that's weird. Why does mine do that? Hate that, that sucks. Hey, is yours set for non-real? Mine is not coming up right. So, because I am supposed to have another side to this, because I am allowed to have negatives inside there. Let's see, let's try and plug in -2. Menu, trace. That's why.
Polar.
I'm set up in polar. I'm sorry.
What's polar?
You'll find out later.
Is it with the circle?
Kinda. There we go. Look. Alright, so now that's better. Okay. So I thought it was your guys. It's me that's messed up. Anyway, so yes, it does work out. We can see now at 2. What can you tell me? Can I take a derivative at 2? The slope. Can I define the slope at 2?
No.
No. What was the special name for it? What did I say? I don't know. It's almost like looking at notes. You know, kind of like talking about stuff last week, right? It's a corner, very good. It's a corner. We cannot find it. It's like finding the slope at a pointy point, right? Yeah, the tip of a pencil. So you cannot find the slope because it balances on that. So you cannot get it at a corner. So let's look at continuity. Is my graph continuous? Is my red graph continuous?
Yeah.
Yes, it is. It is continuous at 2, but continuity does not mean that I can take a derivative. Now let's work at it backwards. So it is continuous, but I cannot take a derivative. Okay, so now think about this. So if I can take a derivative, what do I know about it? Is it going to be continuous? If I can, so if I can take a derivative, is it continuous? Yeah, it must be. By definition, I have to be able to take it has to be continuous to be a derivative. It's kind of like all thumbs are fingers, but not all fingers are thumbs. All thumbs are fingers, not all fingers are thumbs. Right? Okay, in this case, if it's a derivative, it is continuous. If it's continuous, it's not always derivable or derivable. Does that make sense? So, continuity is a good thing, but derivative says it has to be, I can take a derivative, it's not a corner, and it is continuous. So, going back to the notes. So right here, information about this from the graph and its derivative function. Does the graph have any horizontal tangent lines? Horizontal, which way is horizontal? Left and right, okay? Horizontal tangent lines, so that would mean that it would be approaching something but never really touching it, okay? If yes, explain why and identify where that occurs. Okay, this graph here doesn't have that. Does the graph have any vertical tangent? In this case, I have a vertical tangent where? Say 0. Yeah, right here at 0, right? Because it's an asymptote here, right? Okay, it's going to be an asymptote. So right here, this is going to be an asymptote, so it's going up to positive infinity on both sides. Okay, if you have to explain why, identify where it occurs, determine whether the point is a cusp. Okay, don't worry about the cusp yet. Okay, does the graph have any corners? Okay, that's what we're looking for, the corners. Okay, if yes, explain why and where. So see this thing right here? Is it continuous? No, it's not continuous. Can I take a derivative at 2? No. Can't take a derivative because I would be looking for the slope here and the slope here at 2 different locations. Okay? Derivative means slope of the line. Differentiability and continuity. So if a function has a derivative at number c, then f is continuous at c. So if I can take a derivative, it has to be continuous. Corollary, if a function is discontinuous at c, if it's not continuous, then no derivative. So if it's not continuous, automatically no, I cannot take a derivative. Good. Differentiability implies continuity, but continuity does not imply differentiability. Again, all thumbs are fingers, not all fingers are thumbs. Cats, why? Why? So how about this? All cats are pets, but not all pets are cats.
There you go.
Is that better? Okay. Is that better? Okay. This one right here. So this first graph of f, it is continuous at 1. But this one right here it is continuous and the derivative exists because the slope at here from this function on the left-hand side, going this way, would be a slope of whatever this is here, and the straight line here continues that here. So the slope stays the same. From this point on, it stays the same. So it's continuous and the derivative exists at 1. G is continuous at 0, but why does G prime at 0 not exist? It's a corner, right? It's a corner, so it's changing slopes there. So the left side and right side at there are not flowing into the same thing. Yes, it's continuous, but no, the slopes don't go together. Right here on the right hand. So H is discontinuous at 0. So it's discontinuous, so therefore H prime does not exist. So that means at 0, I am not going to get a derivative at 0 because the left and right are not continuous. Even if this did over here, even if they did connect going like this, would I be able to take a derivative there? No. I wouldn't be able to take a derivative. The slopes are different. Okay? What about if, some people were actually doing the homework? You actually had an absolute value function. Okay? Can I take a derivative at that point?
No.
No. Because it is a...
Corner.
Thank you. There we go. All right. Make sure you all like, share, and subscribe. Hit that notification button. Support my channel. Buy stuff from my merch store.